Okay, let's look at the homework 5.4, 5.5, number 7. Alright, so we want to find the area of these enclosed regions. Alright, so let's do that. Alright, so according to the given picture, looks like intersection points are going to be at 2 and also at 3 and at 4. Right? But let's double check. Right? So we have to set these guys equal to each other. So quantity x minus 3 cubed is equal to x minus 3. Right? Then we subtract quantity x minus 3 from both sides. That way you have quantity x minus 3 cubed minus quantity x minus 3 is equal to 0. Right? Then we factor out x minus 3, so quantity x minus 3, right? Because here this guy is in common, and I'll say this guy is going to be 2. Right? So x minus 3 squared would be x squared minus 6x plus 9, right? So x minus 3 is factored out, so you have a minus 1, right, equal to 0, right? Then you get quantity x minus 3, right? Then we can, so this is x squared minus 6x plus 8, so this is just a plus 8. So we can factor it out, so it's going to be x minus 2 and x minus 4 equal to 0. Right? So it looks like x is going to be equal to, from here, 2, from here, 3, and from here, 4. Alright, so these are actually our, the picture looks exactly like that. Alright, let's try to find the region. Alright, so there's a way to assume that these are using a symmetry and I do 1 and multiply by 2, but let's do it separately. So I'm going to call this first region A1 and this second region A2. Alright, so let's find that. So let's find A1. Alright, A1 starts from 2, ends at 3, so it's going to be integral from 2 to 3. Right? Then top curve is going to be this cubic function. Right? So you have quantity x minus 3 cubed minus straight line x minus 3. Right? So we need to evaluate that. Right? I think the substitution works quite well. So we're going to do a substitution. Since I see a lot of x minus 3, so I'm going to let u to be x minus 3. Right? If you take the derivative of u with respect to x, you're going to get 1. All right? So multiply both sides by multiply both sides by dx, and we see that the du is same thing as dx. Right? So this is same thing as, right? So integral, right? We decided to call this guy u, so u cubed minus u, right? And dx is same as du, right? Then conversion would be, so originally x goes from 2 to 3, but corresponding u values are plugging 2 here, so 2 minus 3, so it's negative 1, right? 2, plugging 3 to 0, right? So it's negative 1 to 0, right? Then compute that. Right, antiderivative of u cubed is u to the 4th over 4 minus antiderivative of u is u squared over 2. Right? Then it goes from negative 1 to 0. Right? Plug in 0, you get 0 minus, plug in 0, 0 minus plug in -1, so -1 to the 4th over 4, so it's 1/4. All right, and minus 1/2, so it's -1/2. Right, which comes out to be, so it's going to be -1/2 with a negative, so it's 1/4, so it's going to be positive 1/4. Right, so we have that, and similarly we can do a2. Right, so this is an integral from 3 to 4. Right, the difference is top curve is actually the straight line, so we have to do x minus 3 minus quantity x minus 3 cubed dx. Right, actually the same substitution works, so let's try that. Right, but let's see, upper bound and a lower bound, so you can see that for the second one, x goes from 3 to 4. So u is going to go from plug in 3, 0, and 4 minus 3 to 1. So it's going to go from 0 to 1. Right? X minus 3 is u. Right? U cubed. And the dx is the same as du. Right? Goes through the antiderivative. So antiderivative u is u squared over 2. And the antiderivative u cubed is u to the 4th over 4. And goes from 0 to 1. Right? So this is going to be plugging 1/2 minus 1/4 minus 0 minus 0, which is going to be 1/4 again. Right? So therefore, the area that we're looking for, A, is going to be A1 plus A2, which is 1/4, which is right here, plus another 1/4, which is 1/2. Right? So this is the area. All right, so let's type it in. All right, so area is 1/2. Right, so let's check the answer. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.